Hi everyone. In this video, I want to explain to you why we need the systematic treatment of equilibrium in order to solve some problems. You've probably gotten pretty good by now at solving KSP problems, but if you think about it, in those problems there was only one reaction at equilibrium, and in reality there's going to be more than one reaction at equilibrium, which is why we need the systematic treatment. Let me give you some examples of systems that you might encounter. One example is related to the dissolution of calcium carbonate in water. Calcium carbonate dissociates into calcium and carbonate, and you would recognize this as a KSP reaction. But what if that water were acidic, and what if that acid could neutralize some of the carbonate? So then this reaction could take place. The reaction of carbonate with a strong acid to form bicarbonate and water. I would call this a neutralization reaction, so I'll just use Kn, N for neutralization, to represent that. And then what might this bicarbonate do? Well, it could do two different things. It could behave as a weak acid and dissociate into H plus and carbonate in what we would call a Ka1 reaction, or that would be a Ka2, sorry. But bicarbonate could also accept a proton from water and behave as a weak base to form carbonic acid and hydroxide in a Kb reaction. So given all of these reactions that take place, if someone were to ask you to calculate the pH of a saturated solution of calcium carbonate, that would be a challenge. Here's another example. What if we had some chlorine gas that we were bubbling into water? So that chlorine gas is in equilibrium with its aqueous form. The equilibrium constant here is Kh, where the H stands for Henry's law. And then once that chlorine gas is dissolved in water, it can react with water to form a strong acid, HCl, and a weak acid, hypochlorous. And that has some equilibrium constant associated with it. And then hypochlorous acid can dissociate into H plus and hypochlorite in a Ka reaction. So again, given these three different reactions happening, if someone gave you the partial pressure of chlorine and asked you to calculate the pH, that would be a challenge. So we need a systematic treatment to approach these types of problems where there's more than one reaction at equilibrium. That's why we need the systematic treatment. So notice that we've done a lot with acids and bases in these examples. I'm going to post a video that reviews acids and bases, but I'll make that one optional. So I hope you feel like there's something to look forward to in the systematic treatment of equilibrium, and thanks for listening.